this is my main research topic. Usually I give talk on this, but then in this talk also I move to MIMO system. What are the advanced MIMO system? You have heard MIMO systems, but what are the more things we can do by using the MIMO system? Then visible light communication. Many of your faculty members work on visible light communication. Have you heard this NOMA, non-orthogonal multiple access? So this is also another technology coming to accommodate more number of users, more number of high data rate. Then intelligent reflecting surface. This is another novel technology that which will boost your data rate even 10-fold or 50-fold. Then full duplex communication, doubling your data rate double. Then index modulation. This is also another research topic. Many of your faculty members work here. Then energy harvesting, another challenging of power constraint. So let me go through the technology what evolved with the time. So if you see the 1G communication, a simple frequency division multiple access. So there are 5 users. I can give, or we can give 5 band to the different users. But you see that frequency is a physical, and these are not widely available. So frequency division multiple access for the large number of users. So what we have done, we have divided the entire time to small time slot, and then that is actually 2G communication. Then again 3G communication, and this is one of the great game changer, I should say, that code division multiple access. If you see 2000 or 2020, 2002, at that time there was CDMA mobile system was there. You might not be knowing, but we know. But suddenly this technology failed. Why? Now because we need large number of users, and for that we need to have a large number of sequence, and at that time it was not available. So now there are many research community, they are working on M2Wave DMA, another technology that where we don't have to give a different bandwidth, but we can do sub-carrier such a way that if they are orthogonal, then we can support more number of data. And then we going on, and then this is called advanced LTE or new radio systems, and there we are using all the things, but the main concept is that ultra reliable low latency communication, URLLC, very important term, you can note it down. Then we need more number of users to be supported to the system. So come to the picture 6G. So what we can do, as I said that in the current technology, the parameters are fixed by the base station and the mobile station. But can we change the parameter at the transmitter? And if we change this parameter transmitter, receiver also has to know that what kind of parameters has been changed at the transmitter. So then it's come to the picture identifying such kind of parameters. Okay. Then came to picture this adaptive transceiver systems, and how to, the main goal is to how to increase the data rate. And increasing data rate means we need to change the things in physical layer. So my main talk about this, the physical layer parameters. Then again, in terms of data rate, in terms of that SM applications, those are the applications how we shift from a SMS to internet to internet applications, then massive broadband, all these things. But you see, then 6G came to the pictures, 1 to 10, and 6G we are looking for 100 Gbps data rate. Okay, so for that, not only the data rate, also we need to see that what the new spectrum we can get, then whether we can have a communication with the cell-free communication, we can have a energy efficiency, because once you increase the data rate, that battery issue will be coming to the pictures. So then can we do the energy efficiency and come to the picture of artificial intelligence or blind kind of parameters. Okay, and these are the another set of things that same data rate I have kept, but in terms of security also. If you look at 1G, there is no security. Anyone can steal your data. But then nowadays, all the communication, all the mobile communication or cellular systems, so many transactions is going on, so many important data we are communicating through the mobile device. So without any privacy or without any security, you can have a lot of problems. So now you see there is no security, one-way security, two-way security, then upper layer security. Now again it is coming to the picture that whatever the security mechanism we are having, let's say cryptographic high layer security, those kind of security may no longer be applicable because of supercomputers. Okay, so whatever the cryptographic key you are using at the transmitter or receiver, those can be easily be broken by some kind of supercomputers. So we are having some kind of that physical layer security. So this way we are bringing how AI, ML can be used for security mechanism, or how we can have a mechanism that you will not get data, forget about decrypt the data. So such kind of technology we are coming to the pictures. So now in terms of resource, you can see that for 2G to 4GB, so these are the spectrum available to us. Then 5G, this is the sub 6 GHz. Also we are using this one. And 6G actually, if you see the spectrum is available from here to here. Even these are also we are trying to explore. So the huge band is available. So this means we can have high data rate. But what is the problem? If we move to the high frequency, the distance will be reduced. We cannot communicate to the large distance. Why? There is a path loss. To break this path loss to small path, we will be bringing some kind of technology I will mention later. It's called intelligent reflecting surface. So instead of having a RF for long distance, we can have a mid of the range of the communication. We can put a device. It is a passive device which can reflect your signal to the destination, and without needing any radio frequency chain which needs more power, such kind of things. So then this is a bottleneck, but we need to bring a technology where the path loss can be resolved. So then also that visible light communication come to the pictures, and then this is the different. We cannot use such kind of technology for the communication purpose. So this is the resource. Why we are looking for the 6G communication? I think objective is clear that why, because we will get huge bandwidth and data rate can be reached to 100 Gbps per second. This one, visible. This is a kind of visible light communication. Yes, but in terms of gigahertz, it will be after the 100 gigahertz we call terahertz. After the 100 gigahertz, it will be part of the terahertz frequency band. So, what is the objective of 5G? You see there is three angle. One is that enhance mobile broadband, EMBB. You may note this term. This is very important. Enhance mobile broadband. Then, as I mentioned that machine type communication. That that now we are doing communication between human to human. The machine will communicate. Now realize in industry how many machines will be there. So then every machine will communicate to each other. So we need a very huge data rate. We need also densely populated communication device. So then accommodating such kind of things, we need a different kind of technology. Then ultra reliable. You have often seen that you are communicating, your call get disconnected. Now, if number of users get increased, so this connectivity will be an issue. So we have to find a solution where connectivity will be not an issue. And they can support also more number of users. And also in a 5G technology, we are looking for a horizontal kind of communication area. But in 6G, we are looking also for the vertical. Like there will be drone technology will be coming to the pictures. So where lot of drones also will be communicating to the ground. So you see that most of the places, and you know, I am giving one example. Let's say we need to communicate or need to transfer 1 GB data from transmitter to receiver. Then the data rate has to be double, almost double. 1 GB file, you need to have a 2 Gbps, 2 GB transmission. Why? Because along with the communication, we send some header. We send some package which is not relevant to the data, but which is relevant to the channel, relevant to the connectivity, finding the users. There are so many network issues there, so we have to keep the overhead. So the main goal is to hear that how this overhead can be reduced. Because some of the overhead used to identify the parameters, identify the users, identify the users node. So now the question is that, can we reduce this overhead? Yes, we can reduce this overhead, but we have to develop another kind of technology which can help in spectrum efficiency. So one of the main objectives for 6G communication, that how overhead can be reduced, and whatever overhead you are reducing, you cannot degrade your quality of service. So to improve the quality of service, we have to adopt some kind of technology. So then one may ask the question, why we need to have AI ML? I'll give some kind of research what we have done, that even if we move to the machine learning AI, still our performance can be improved. One thing, and second thing, that I have another slides, that why AI ML is very, very important for the future communication. Because sometimes, you know, we assume that channel is AWGN, additive voice Gaussian noise. Channel is Rayleigh fading. Channel is Ricean fading. But those are the assumptions. Those are the mathematical model. So it may not be equal to the practical channel model, practical noise. So when we do the theoretical studies and derive all the equation performance, when we apply those methods in practical system, what we find, you know, we find that there is a loss. Our study does not match with the practical scenario because of those assumptions. But machine learning, what will do? He does not need to identify this is a AWGN. Whatever the channel, he will learn from that channel. If it is whether it is Rayleigh fading, Ricean fading, it does not matter. He will update the parameters based on the input level. So performance gets improved by using AI. But the question is coming that, what is the difference between AI ML in computer science and our wireless communication? You see, the computer science, almost all the levels are, all the modules are black box, because the noise is not there, randomness is not there. But here we are communicating through the channel. Channel is totally random in nature. So we have to modify such kind of module. We cannot blindly use such kind of module in communication. That's why those AI ML module is not kind of black box. Here we call it gray box. So you see that 5G is with these regions, and 6G we have just crossed the boundary of 5G in terms of many: extreme high data rate, extreme coverage, extreme low energy cost, and extreme massive, extreme high reliability. and extreme low latency. So you may ask again, this 6G communication already, the government already started progress, and already they made a committee, and there are so many activities going on, and we are trying to do such kind of 6G, and that is my main objective, to give talk on the 6G communication technology. So I already mentioned that why 6G we are moving, that adaptive, time efficiency, high spectrum efficiency, power efficiency, and cost efficiency. So this slide I have not changed, just except this one, and this slide I made 2010, same slide. Objective was what? That irrespective of the technology, we can design a receiver which can receive all kind of signals. What is the advantages? You see the any questions? So you know that our mobile device, how many transmitter receiver we have? Do you know? We have so many transmitter receiver in our smartphone. We have Wi-Fi, we have GPS receiver, we have GSM receiver, we have Bluetooth receiver, and this every receiver they have RF chain, and RF chain is very much power hungry. So that is the reason your mobile battery get dying by day. But let's say if we can replace all the transceiver by a single receiver chain, then your power battery survive for 1 day. It can extend to 5 days. It can extend to 6 days, right? But designing such kind of receiver is not so very easy. So when I mathematically developed such kind of concept, it was one of the defense project of Singapore defense project. So many people object that okay, this may be mathematically possible, but practically not possible. So I developed a test bed that okay, this is not impossible. But then when we are moving for OFDM or MIMO OFDM, the performance get degraded. So last 5 years, then again I shifted to the machine learning. So I am working in this direction for the last 13 years. So objective is same, but technology inside the algorithm we have changed time to time. This slide also I have not changed. I made this also in 2010. So what is this is the basic structure in a mobile device or a receiver. A receiver signals, RF signals, then convert to the baseband signal by moving the RF signals. Then it's estimate and to do that, you need to identify that what kind of IF or RF carrier is there, and then you can estimate the symbol rate, you can do the modulation classifications, you can do the timing synchronization, the frame is coming. So you have to understand that starting point of the frame. Then you have to identify the frequency deviation that due to the Doppler effect, due to the transceiver oscillator mismatch. So those we have to identify. Then we can get a exact baseband signals and compensate all these things and get a constellation diagram. So this is a very basic structure of physical layer communication. I am not moving to the upper layer yet. So then from there, constellation side, there will be some channel error will be there. We can do the channel equalization. Then we can get the exact information. This is for single carrier systems. Now all the modules we have developed by using a statistical methods. Now all this module, all this block, again we have replaced by machine learning. And the beauty of the things I can show you by some simulation results. This is the motivation why AI ML is required. I already mentioned. So I am moving to the further. And this is for the OFDM systems. Because single carrier, whatever the parameters, OFDM system parameters are different. Why? Because single carrier, we insert the bits in the time domain. But OFDM, we insert the bits in the frequency domain, conceptual wise. Why we do such kind of things? Then because there are so many channel parameters are there. If you know the OFDM, then you will be knowing that it converts a frequency selective channel to flat fitting channel. So your equalizer complexity gets reduced. So your cost of the device gets reduced. And there are many more things we can use the OFDM. But you can see that if we want to make this device blind, means adaptive, blind, adaptive, intelligent, they are the same terminology. I am using a different way. Then you need to understand that symbol length. You need to understand modulation classification, those were existing single carrier system. But along with this, you have to understand cyclic prefix. This we use to remove the inter-symbol interference. Then number of subcarriers, because how many subcarrier do you use? So you know that Wi-Fi we use 64 subcarrier, but for the 5G, even we can use 1024 subcarrier. And when you are moving vehicles, very high speed vehicles, that time number of subcarriers again need to be very high. Why? Because we need to adjust with the channel so that the signal coherence bandwidth will be lower than the channel coherence bandwidth. So that time you will not have any problem. So then we do the carrier frequency offset, and these two parameters is very sensitive in the OFDM systems. Even if you have a one sample error or two sample error, you cannot deconstruct your signals. You cannot deconstruct your signals. So this has to be error free. Then we did so many works how to estimate by using a statistical methods, and now we replace by machine learning models. And here some automated modulation classification. Many of your faculty members work in this direction, and so let me give some overview why modulation classification is required. I hope you can understand this picture, right? This is base station, and base station they have different kind of circle, you know. Have you seen the tower or base station? There is some circle kind of antenna. So they target a specific region. So they target this region, and where the energy or power of the signal is very high. So since the images are nearby, so we can support very high data rate. But when the signals come to here, due to the path loss, signal strength get reduced. So at that time, if you want to communicate with high data rate, your data will be not reached to the receiver. So what do we have to do? We cannot use very high data rate. What does it mean? This means we can transmit 4 bits, 5. So 5 bits at a time. But in this case, we cannot transmit 5 bits at a time here. Then there will be error. So what we have moved? We have moved 4 bits at a time. Then again here, 2 bits at a time or 1 bits at a time. So this number of bits, if you increase in a simple duration, then data rate will be very high. I think many of you have studied modulation scheme, right? So when we move to the classifying the modulation scheme, he can demodulate the signal and get the information. So this is the main motivation of adaptive modulation classification. Now this is a some kind of structure and schematic diagram in a mathematically you can design. Now you see the results here. These are some parameters I have used, simulation parameters. So what number of subcarriers, then what is the STO, all these parameters I have used. You don't have to understand those things. Now you see, come to the results. So this is accuracy. This is the SNR, the received signal power, and those are mainly statistical methods. These are the AI machine learning model. So what interpret this one? That at 20 dB SNR, that the accuracy is 50%. Means if you send 100 times BPSK, so receiver 50 times will classify, okay, this is BPSK. And another 50 times it will misclassify. But this means 95% accuracy. Means out of 100 times BPSK you are sending, the receiver will classify 95%. And another 5%, because if it is misclassified, then you cannot reconstruct the signals. So recently we are using kind of digital twin. Have you heard anyone digital twin? So we are using some kind of outer IoT device coming to the pictures, that from there this 5% gap we are going to remove, and that research work is going on. So now come to the pictures. Okay? So my research part is done. I am not going to much research direction because you will feel bored, and I can able to realize that. So what is the difference between this one? You have looked this one might be 2005, and nowadays you will find very less such kind of towers.
Sit down.
So you will find that this kind of base station nowadays, and this is futuristic. 2030 we are going to have such kind of base station. So what is the difference? You know, they are targeting some kind of specific region, but in this case they are also targeting some specific region. But you see, this region actually targeting some specific region with a multiple antenna. But the multiple antenna that is coming to the pictures, and this is another multiple region, one region. This is called the MIMO concept. So this concept started research in 2000, but application came to the picture in 2010 or 2015, and nowadays everywhere you can find this. And in the futures, this is called the massive MIMO. Massive MIMO. So this kind of MIMO will transmit. Without this one, we cannot achieve a very high data rate. So this kind of picture is becoming, and I'm coming to the technology of this. How does it work, this kind of MIMO systems, and how such kind of massive MIMO works in the mathematics. So very simple mathematics. Okay, if you know the linear algebra, BTech first year, right? Linear algebra, matrix multiplication, and matrix inverse. If you know this one, it is very clear pictures. So you have a data. Data may be some 0, 1, 0, 1. Just try to understand. It is very simple things. Not any research is going on. Then we do the modulation. The modulation means, I cannot transmit 0 and 1. I have to transmit some kind of electromagnetic wave. And electromagnetic wave, they have phase and amplitude. So different data we transmit by different phase and amplitude. So that's why we need to do the modulation scheme. And if you are third year BTech, I hope you know the modulation scheme. Now we do the power normalization. Then we divide this data. There are so many processes like channel encoding mechanism. Then we convert to x1, x2, x. So forget this tilde. This is nothing but x1, x2, xn. So there are n number of antennas. So what we'll do? This data will transmit by this one. This data will transmit by this one. So actually, this is called what is called this one? This is called the
reliability.
No, not reliability. The opposite. The multiplexing. This is called the multiplexing. But if we transmit same data here, it is called the reliability or diversity gain. So you see, this data we are transmitting here, but the receiver, how many data coming? This data, and this one, they are actually different channel, and they are giving different kind of channel response. one is H1, one is H2, one is H3. So you see at the receiver actually we are getting three different data by the three links. Sorry. So this Y1 actually nothing but a Y1 nothing but a this multiplication with this one, this multiplication this one, this multiplication this one. So we are receiving Y1. Here we are receiving Y2, Yn. Now we are arranging those kind of things. Now if this is system of equation, right? Forget this one. This is system of equation. Now if I know this H and if I do the inverse multiply here, then I can get back x1, x2, x3. So many MIMO. You go back MIMO can increase the data rate. Then why we are not having a 100 MIMO? The problem will be coming that those channel response will be the same. Now come to the matrix again. If this row and this row become same, then I cannot apply inverse. Because if they are independent, if they are dependent, then the determinant will be 0. I cannot do the inverse, so I cannot get. So you see, this is the basic problem of MIMO. So that's why you are having the Wi-Fi router might be here, having 4. Why not 10? Because if you have 10 or 20, then you cannot receive the data. So now the problem coming to pictures, you see, pictures here, 1, 2, 3, 4. So, and you see this difference has to be some difference. What is the difference? I am not coming to all. Diversity, we are sending same bit again and again. So if this link gets failed, I can receive the data by this link. But here we are sending 3 bits in the different bits. So this is called the multiplexing kind of things. Now what we had, that massive MIMO, the number of antenna will be very high. So you see here we are user 1, user 2, user n. They are actually in a cell, they are placed at the different place. So the link ideally has to be independent. So that this link and this link, you see they are the different color, means they are not same. This means we will not get a row which will be dependent, which will be identical. So that I can or we can apply a inverse and we can get the data. So this massive MIMO concept will be applicable to the cellular system, but not inside the indoor communication. Then what is the thing? Now one more thing, if you see, if I have a multiple antenna, so this is nothing but a RF chain. This is another RF chain. Please stop me 5 minutes before because I have so many slides. Okay, just stop me 5 minutes. Yeah. You picture that. So these are very power hungry. So having so many antenna is also not good in terms of power efficiency. So then, is there any other way? Yes, there is a solution. You see that so many constants. If I reduce number of antenna, my data rate will get reduced, but that we don't want to compromise. Then it's come index modulation. Some of your faculty members also work on index modulation. Now coming to the, have you heard this one? Non-orthogonal multiple access. This 5G, 6G, how come to the pictures? Because there is a body, every year they release some kind of technical specification. So this NOMA till 17th release, it was very powerful technique. What powerful technique? You may know this FDMA. I told once, TDMA, this was introduced in a 2G. Then CDMA, it was introduced in a 3G, right? So these are the frequency. Different frequency, I can send the different data or different users. This will be first user, second user, third users. This is a first user, second user, third user, fourth users. I can combine these two. This is a frequency CDMA, different code will be used for the different effects. Even we can combine all these things. The complexity of the receiver, transceiver will be increased, but still there is some limitation. So, is there any other way? And this is called a OMA, orthogonal multiple access, PDMA, FDMA, CDMA. But the question is coming, can we transmit in the same frequency multiple users? Then one resource, but still transmitting different data. You see the pictures here. So in this case, we are using same frequency or same time, but user 1 using some level of power and user 2 using different level of power. So user 1 has some level of power, user 2 different level of power. So this variation of power, we can transmit more data. So this become a, can you see that the spectrum not double, but the data rate actually becoming double within the same time or same frequency band. So what are you going to have this one? So if you see this one, then we can have a user 1 and user 2, they are using the same frequency but different power level. This is the power user 2, this is for user 1. User 1 using some kind of frequency band. If you the Shannon channel capacity, then you can be knowing that the frequency used less, the data rate also will be less. But in this case, no more. We are using the same, much more frequency, much more time, we can able to double our data rate. Not exactly double because there are so many power conditions. I am not going to details of this one. And you see how we can do this one. So in one cellular system, we can create a cluster 1, we can create cluster 2. Cluster 1 will be this U1, U2 may use two different frequency or different time slot, but this one and this one will use the same spectrum. So I can support the 4 number of digits. So not only that, you see the real practical example that one cellular system, I can have a cluster 1. They will be using the different frequency, but this one will be using the same frequency. So this way we can accommodate more number of users in a practical scenario. So you see that how NOMA is very powerful. Obviously, there is a successive interference cancellation mechanism need to be developed. There will be so many interference, so those interference has to be removed, and sometime more number of users you are having, then there will be more complex or more power hungry will be there. So those are the kind of challenges. So those if we can able to remove, then the data rate will be improved further.
What will be the trade-off then?
Trade-off. Yes, like MIMO, we have this is a trade-off. This is a trade-off. We are having 4, so I cannot have 10 because 10 then there are a lot of complexity there. So this is the trade-off 4. But again, trade-off will be increased with time. So if you remember, before it was 2, now it is 4. But again, it is not stopped here. Engineers are there. They can move to again 6. They can move to 8. So currently timing is that we are having maximum 2 or 4 clusters. But with future, it can be increased. There is no trade-off. Trade-off is just only for time being. Yes, complex, but there is people are solving this complex problem.
Coming to the line of NOMA, this concept called as an LDM, layered division multiplexes, where the user can choose different power levels
Yeah.
to be operated on. It is one kind of NOMA, one what you are just now telling about.
Yeah, it's a power.
Power level. So they call it as a layered division multiplex.
Yeah, you can say. But there is another technology is called the sparse code multiplexes. This is a power domain NOMA. there is also codomain NOMA. Codomain NOMA. So there are also a lot of challenges are there. Yeah, but again I said 17 release of 3GPP. Have you heard the 3GPP board, right? 3GPP group. So 17 release, they included NOMA, and many of the industry they are interested to develop. But as I said, trade-off, they cannot. If you go more number of users, the power level will be very less. So differentiating between two small power level becoming challenges. So now instead of that, they are moving to full duplex communication. Because NOMA, even 2 users, you cannot achieve double of the data rate. But full duplex, even we can able to achieve the double data rate. So most of the, because last meeting we had a meeting with the Nokia, we had meeting with the Qualcomm, even we had meeting with the Samsung. So they are interested nowadays full duplex rather than NOMA. Yeah. So should I move further or let's stop? Yeah. Another very powerful technology, intelligent reflecting surface. It has different name also. It has large reflecting surface. There are so many names are there. I'm not going to that different terminology. So as I said that this is and you have a very high-rise building, and now you want to communicate to this guy. So you see there is no line of side communication. So what you can do? So this is called the satellite region, So some of the data, some of the signals can be reached, but you cannot install a base station everywhere, right? Base station is very power hungry and very costly. So many things need to be taken care. So what we can do? This is an intelligent reflecting surface. It is a passive device. It does not convert to baseband to RF or RF to baseband. So RF to baseband and baseband to RF, it takes a lot of power. So whatever signals will receive from here, I think I am shouting because of this sound. So sorry. Is it okay? Okay. So what happening? This passive device just reflect the signal from here to here. Does not need any power. Just what things need? He needs a back connection to identify where the signal, where the users are placed, and based on that, he changed the angle of departure. He changed some slight variation of this amplitude, and this way we can divert the signal from here to here and then here to here. So we can avoid this blockage. And this technology is so powerful. You see that currently, let's say, and back also. This one can reflect to signal here, signal here. Now consider the scenario GPS. GPS is one-way communication, right? We receive the signals, we cannot revert back to the satellite. Otherwise, So, what is the advantage? Just I'm giving a little bit of mathematics. Very simple mathematics. This is my signals. This is the noise term. Forget about this noise term. This is channel, multiple channel. This is the power we are transmitting. This is a single input, single output. Very simple communication systems. This is the mathematical model. And this is a channel capacity formula. Log 2, 1. Bandwidth I have assumed 1. Log 2, 1 plus receive signals and by noise. So you see, this actually, if you increase these parameters, then your data rate will be increased, right? Now, you move to these systems. This is a one channel model, this is another channel model. So, the received signals I can write Y. This channel model is this one, and these two channel model is this one and this one, and this is signal, this is power. Now you see, if I calculate the SNR, this is the data rate. You can see that this term will be increased by increasing the value of n. You see, if I increase n, then my signal power will be more. But there is some certain limit. So because you see, you are sending the signals, right? Path loss. Because different directions are going to the different and giving the signals, right? So if you have a reflecting surface, it can divert the signals and you can capture all the signals coming from the different direction, then your power will be increased, right? This is a very concept, like, you know, we had I always give some example that you think about the 5,000 years back. That time neither we had a train line, neither we had a highway, we had some kind of surface, we had to move from one place to other place. How difficult it was. Now we are making a path and now moving the, so similarly. So wireless communication, there is a raw path, signal path. Now we are making a nice path by placing such kind of IRS reflecting surface. Actually we are moving to a high speed path. Okay, so for the wireless, you think that way. Now what is the metamaterial? It's a very thin layer. It has a composed of 3 metals surface. One is a reflecting surface, and behind there is a copper surface to avoid the absorption of the electromagnetic wave. And the last part, and it is the thickness will be millimeter, 1 millimeter, 2 millimeter thickness. And you can post such kind, you can place such kind of device here also. You can place there, let's say signal is, you can receive the signal from the base station, there will be rooftop, there will be some kind of surface, then that signal will be reflected to the auditorium so that you can receive more signals. So this way, this is a place, and now this will be reflecting the signals here and reflecting signal here and different users. Okay, and you know, let's say there are 3 users. So let's say this lower, this one can reflect the signals here. This reflect the signal to here. This can reflect the signals here. So we can serve even multiple users. Same different signals, we can deviate the different angle and we can receive the signals.
How will the mobility of these be taken care?
Yes, obvious mobility. That mobility, you know, this I have to just change page. I just changed the this page, that departure of angle. I have to change with the time because I am having this location of this one, because it receives each signal, send the signal to here and receive the signals here. He calculates the position of this one, and then there is a line passes to here, control the things. Based on that, we can do.
Latency compared to LOS, IRS?
Yes, latency, but again, latency, those things we can take care by other way, latency, all these things. Yeah. So mainly you see, let's say here, right? My problem is where there is a no non-line of sight problem, there we can use the communication. But here, I have to support more number of users. You see, all people are sitting, right? So I can serve at this moment, they need a very high data rate. I can use a IR, visible light communication or whatever, I can support to the people, right? Yeah, that is the concept. So you see, another application is that this guy is eavesdropper, stealing our data without subscription, without things. He's watching the movie from the Netflix. Okay, I don't want to send the data. So then, you know, if I know the position of this one, authentication, through authentication, I can send the signal here, but not to here. So this way, this is called the physical layer security. This is another very huge, demanding research problem, physical layer security. So this way also we can prevent our, we can make a privacy to our communication. This is another slides. You can see that how we can do. This is you see rooftop, and this is a auditorium and lab. So this one and this signal coming from here, reflecting. So many people can serve in indoor communication. This is a remote place where I can, this is reflecting surface element. So I can through the drone, I can have a signals, and then I can transfer this one. Now you see the real pictures that automated vehicle systems. So automated vehicle system, you know, they need always communication, high speed communication. And you know, in the urban area, so having a line of sight communication is very, very difficult. So we can have a building, we can place this intelligent reflecting surface, and then we can direct the signals to the vehicles, and vehicles take the data and then communicate. So you see that intelligent reflecting surface, and this talk even I came to Chennai, that one of the researcher from USA, 2018. So when he giving talk on this intelligent reflecting surface, I thought this is may not be practical, you know. But nowadays there are so many work is going on, so many industry, so many company already started to developing such kind of IS reflecting surface. Even in ISC, we are going to have a test bed by using this intelligent reflecting surface. Okay, so it has a huge future for the high speed communication and where the line of sight is not available. Okay, so I'm stopping here. So I have